Hello everybody, what's up? In this video I explain for you another classification algorithm, a Kelly's naive Bayes, okay? It's a probabilistic algorithm. I love it. I love this algorithm. It's one of my favorites. Next video I explain for you decision trees. Decision trees is my favorite algorithm ever. So here I explain for you the mathematical, okay? The old-fashioned way here, there, okay? When you finish this video here, I recommend you go to the GitHub. There's a link here in the description, you click and you go there. There I explain how to create it with Python and real data. I use data of the Kaggle. I love the Kaggle. Here, only mathematical. So, let's go. So guys, naive Bayes. What is naive Bayes? It's basically a probability algorithm, okay? We represent the algorithm with the Bayes theorem. What is the Bayes theorem? It's basically we will play with a conditional probabilities. But what is a conditional probabilities? It's basically this formula here. But what is this? The letter A is basically your targets. I will represent this conditional probabilities with using an example of datasets, okay? We have in the datasets there's a target and the features, okay? The targets is a goal of the model, and the features have a relationship with the targets. I give you a little example. If I sales ice creams, okay, my features will be something like the temp and the weekends. Is the weekends or no weekends? You have two features, and the targets will be something like the sales of that specific day, okay? If the temp is hot, okay, and it's weekends, oh god, I will say a lot of ice creams, okay? You agree with me? In otherwise, I didn't say a lot. I won't say a lot. So this is basically the features and the targets, and there's a relationship here. That's conditional probabilities say for us. That formula say how change the targets happen if the features happen. Okay, here we represent only one feature. Okay, but if we have a lot of features like 10 or 3, I will use 3 here. We only write here B1, B2, and B3. Isn't mystery here, guys. So when you're talking about a term of the Bayes term, we're talking about, sorry guys, we're talking about that specific formula here. Okay, behind the big probabilities. But it's a little confusing. You see something like that here. But no matter that side here, no matter. We will clean here, okay? And we have only this formula here. But what does this formula say for us? The probability for the feature happen if the target happens plus the probability of the target. We use this for classification, but how we take this specific formula and do a classification is a little messed up, but I'll explain for you. This letter A here, I will represent the class, okay? I will represent two classes here, span or no span, okay? Okay, I will write here. Here is a class, okay? The class of the model. The letter A is a class. In this letter B, I will represent the features. A new feature, but because the model will classify new features, okay, new values, and this letter B will build a new, okay, new, basically new. The classes here, I represent two classes. The most common use for this stuff is classification span, not span and mail. I will write here a dataset like span, non-span. Okay. Span, non-span. We have words here. We have sentences more common in email. Your model will be trained with emails, okay? That emails have sentences, have words, and I may one specific email, specific span email, have and yours, okay? Specific words, and these words probably will happen in other emails, span emails. Have a relationship here, like click here, money, or something like that. Okay. Uh, these two rows represent span emails. If you see an email, first of all, if your email beginning with click here, money, so guys, this probably will be a span email, okay? Span email. A non-span email is like if your friends send an email, it's like friends, buddy, and school, or something like that. It's non-email, okay? And span represents with that here. But your model trained with that. Your model will read a mail and classify it. If come up with another words, we never seen that, like another words like ice queen, okay? Like ice queen. Like ice, okay? Ice. Since ice needs be classified for your model, and for and that ice here will be the new words, and we substitute it, okay? This is for ice. How chance the ice is non-span or span? Your model will classify it. We use data, numbers, but I won't calculate here because this video will be so long. But if it's a sentence, okay? If hello, my friend. Hello, my friend. So now we will do we have types, okay? I want to explain it. We have two types of base term when is one feature and is one or more feature. For represent one or more feature, we write a little different here, okay? We will write like that here. When is one is two or more features, we represent something like that here. I say that B1, B2, and B3, okay? The academic papers represents multinomial features, a little different, very dense for mathematics. Here, that formula will be very simple for understand very well. So it's basically that here. Here we do an inverse, okay? We take the B, starts with the B and after the letter A, okay? We do inverse here. This stuff like carrots likelihoods, okay? But you isn't understand it right now. It's like likelihoods, okay? Probabilities the B, okay? Plus the probabilities of B3 plus the probabilities of the A. Behind all of the probabilities. Behind here, this denominator here is basically all of the features, okay? All of the new rows. the B1, B2, and B3. It's basically this. But I talk about it. We clean here, that's the denominator here, because cut for the up. And we have only that here, okay? That is a formula of multinomial features, okay? We have types of a naive Bayes. We have multinomial, Gaussian, and Bernoulli. The multinomial work with integers numbers, okay? This is words, but the model say only numbers, okay? We represent these words here like numbers, okay? 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, something like that. It's basically numbers here. Your model work with numbers. In natural process language, the model, the transformers see the words, okay? See the sentences, but it's basically numbers. See only the numbers, okay? Binary numbers. And we represent it like that here. And in the one, we take hello, my, B2, and friends, B3, okay? And letter A is basically the class. Isn't mystery here, guys? Isn't mystery here? But there's another, okay? I will clean here for a better entertainment about this model here, okay? I will clean here. We have the model, okay? The model. And we take a new road, okay? New. And this new road pass for the model, feed first for the model, and this model will classify for span or not span. It's basically that here, okay? Isn't mystery. It's very simple. My goal here is explain only the concepts. If I will explain all of the dense mathematics, this video will be so long. I explain for you. We have types of naive Bayes, okay? We have multinomial, first of all, multinomial. There's two Bernoulli, and there's a Gaussian, okay? And Gaussian. The Gaussian is a little different. I work with Gauss distribution. Gauss distribution is normally called a normal distribution. But I want to explain here normal distribution. I want to explain for the formula of the normal distribution here. It's basically here, that's here, the Gaussian. Explain for the Gaussian right now. The formula of the Gaussian is basically, okay, the class equal the one behind quadratic, okay, 2p, oh man, right, better, 2p, okay, number of Euler, we use number of Euler here, if I remember it, is x, okay, x less, okay, less this number here, quadratic, 2, okay, I remember it. That is a formula of the normal distribution. But what is a normal distribution? It's very simple. You want to need to understand this formula here, it's a little messed up. But the normal distribution is a statistic model, okay? A statistic distribution. But what is a distribution? Take values and distribution, okay? One piece for you, another piece for you. It's basically that here. The ONU classifies the KE rank, okay? There's a KE rank in the roads. You, one time in your life, you see something like that here, okay? Something like that. Here, there's the normally people, okay? Like 100 of K index, okay? Here is the most smartest people, okay? These more smart people is like the genius, okay? Genial people, like Albert Einstein, is not Nikola Tesla, and me. So it's fun. I want a genius. It's like Albert Einstein here, like Albert Einstein. There's here is the less developed countries, 3 world countries, okay? People less smarter than that here. The Brazil collocation, my country, the index of KE is 87, okay? 87, if I remember it, is 87. I want to enter in K rank, in my opinion, is social desigualdades, but you need to understand this concept here. We represent your population in a range, in a rank, okay? But how this algorithm classifies? You understand, it's a rank, okay? But how the algorithm classifies? I'll explain it for you right now. I will write again here. Normal distribution, carries normal distribution. Normal distribution, okay. We'll take a range, okay? A range. We see our data set. Gaussian work with non-integers numbers, okay? Non-integers numbers. The multinomial work with integers numbers, okay? Integers numbers. The Bernoulli, I want to explain it, work with integers numbers too, but it's a little different, work with a binary integers numbers, okay? 0 or 1. Is the most common for use for presence of a student in a classroom or something like that. Is integers too, but binary, okay? Binary. The Gaussian work with non-integers numbers. Non-integers numbers, okay? We'll take a range here. I will give a little example. Something like we have heights of peoples. I non-tall, okay? I normally in Brazil is 1.70 probably. I'm short people. My tau is 1.70. Okay, yeah, 1.70 of tau. I don't very tall like a basketball player or something like that. We will classify here. We model of normal distribution. This is your model, okay? Here is normally. The normally, tall, and short. And short, okay? This is our model. I will represent that model here, okay? With another color, like blue. I will represent the Gaussian with the blue, the model of Gaussian. Model. And we take Gustavo. My name is Gustavo, and I will drop here, Gustavo. Enter for the model. Gustavo have 1.70 of tau, of height, okay? 1.70 of height. and the model will classify with three classes here. We have three classes, okay? Normally, tall, and short. The normal range is basically 1.70, the tall is 1.90, and the short is 1.50. Okay, is a short guy like Asian peoples. Is more short than Australian peoples or something like that in our hand here. And Gustavo will pass for the model for this normal distribution with that specific count. I won't explain it. And it's basically will be the normally, okay? Normally. Will be the normally. It's basically this. But when I will go back a little and talking about a little of if your model training, okay, with a specific data and test with another data never seen before, this data will be normalized for take that specific model, okay? This normalization basically carries smooth Laplace. I won't explain it. But what is smooth Laplace? Basically take these new words, we talked about these new words, okay? Basically take these new words and drop a value for that word, specific words, okay? We represent this formula of smooth Laplace. I will clean here, guys. It's a little messy up. I will write like that here. Smooth Laplace. Smooth Laplace. Okay. The formula of smooth Laplace is basically theta equal 1 behind n plus alpha d. We represent the run up here because that's new roads never seen before, okay? If that roads like is seen in Spain and isn't in non-Spain, the Spain, because the Spain, there's in Spain, will take a value and we represent with an int, okay? That int is a value of Spain. That's theta, that's alpha here, we represent for 1. It's more common in the papers academics represent for 1. But if this word never seen before, like a new word never seen, we will clean this x here and it represents only for the 1. Oops, guys. Represents only for the 1, okay? It's basically that here. That is the model, okay? Naive Bayes. Naive Bayes is basically a classification algorithm, a probability. We have your model. We have new words, new features, pass for the model, and the model will classify for the classes, okay? It's basically that here. Is very dense, mathematical says. Here I try explain it more clearly, more easily. If I explain all of the concept here, oh guys, this video will be so long. And here I try explain it a little more easily. So, I thank you for watching this video, okay? I will finish here. I recommend to go to description, okay? In the description here, there's a link, you click and go for the GitHub. In the GitHub, I explain how to create with Python, okay? And real data. We have three functions, Bernoulli, multinomial, and Gaussian. I will use these three functions for and three different datasets for training your model, okay? So thank you for watching this video here and see you later. Goodbye.